Right now?
Yes.
Yep.
Good afternoon, everybody.
Good afternoon.
Okay, so today I'm going to talk about work, energy, and power. And the unfortunate thing is, if you've never taken a science class, you ask somebody, what's the difference between force and momentum? They'll say it's the same thing. What's work? Oh, that's like power. What's energy? Oh, that's like a force, right?
Yeah.
Unfortunately, people don't know the difference between these 5 words, and there actually is a difference. So in groups of 2, what I wanted you guys to do is I just want you guys to fill out the second column. Everybody look up here. Just fill out the second column with your partner. I just want to hear a lot of talking. Make sure you guys are asking each other what the meaning of force is, the meaning of momentum, energy, work, and power. It doesn't matter if you get it wrong. Eyes over here. Thank you so much. And leave the third column blank. We're going to do the third column together, okay? So, unfortunately, some of you guys are not sitting with somebody else. But if you're sitting by yourself, you can work in groups of 3, right? Yeah. So you can work in groups of 3. Eyes over here. Yeah, you can work in groups of 3. You can work in groups of 3, and you can work in groups of 3, right? So I'll give you guys a few minutes to fill out the second column. Do we fill out the third column?
No.
No. Okay, good.
No.
So start now.
Hey guys.
What's the definition of force, Mia?
It's a pusher or a pull. A pusher or a pull.
So force is a push or pull.
And then what are the units? Isn't it a Newton?
Yes. I feel like there's a camera right on me. Fucking narc.
Wait, you're not in the frame.
If you get it wrong, it's okay. I'm not going to take any points away from you.
She's gonna take all the points.
Kind of greedy.
Mr.
Okay.
Simpson's an arc.
Momentum.
It's just my face? Or
No,
just my
it's just
body?
your body. There's no face.
Okay, thank you for telling me that. You know what? Could you be the camera woman? Mm-hmm. Thank you so
I want
much.
to be the camera.
I would be.
I'm sorry.
You know, actually, I
disappointed her. Hey, that's not a big deal. Thank you so much.
Class, so I think I'm more appointed than.
Wait, so like, what do I do?
You just move it to where he's at.
Just get me. This is my good side. Just kidding. I don't have a good side.
I heard it.
Wait, guys, we actually need to do this.
Wait, guys, I really don't know what momentum is.
It's speed over man.
Speed over impulse? Oh, time over force.
Oh yeah, she's in varsity. You can only go for varsity.
Wait, isn't it force times time? Are you leaving?
Get tracked.
Yeah.
Looks like I have tracked.
You're dumb because you're not in cities.
Oh yeah. I was never in track.
What is the units for momentum?
I don't know. Oh. I don't know.
You gotta know what momentum is.
Yeah.
I put that it's force times time.
It's like
Force times time. That's what I put.
Oh yeah.
momentum of the dick.
Don't say.
Oh,
And I put in my
sorry. I just
You guys know what a force is?
I apologize.
Oh, you're right.
Could you not mess with this? Because you're also messing with my grade.
Oh.
Sorry.
Yeah, it's okay. Yeah, just, you guys talk, right?
Wait, how do you pronounce your last name again? Okay, Mr. Ahmad deserves an A. I know.
What are the units?
What?
What are the units?
I know she's Chrissy.
What are the units?
I'm camera shy.
What are the units? Does anybody know what the units are?
Okay, tell me if my pencil's in the shot.
I don't have time for you right now. I have to do work.
He's gonna show us the answers anyway.
No, it doesn't matter. We still have to do
Wait,
work.
is my pencil in the shot?
Energy is
I don't want to be in the camera. Is it in the?
yes,
that doesn't
light.
work.
What about now?
No,
Now?
yes.
Now? You're lying, dude.
I swear. Light heat, work. Light heat. I cannot think of anything else. Light heat.
guys have questions?
Light.
Hey, Mr. Simpson.
You have to know the definition.
Can I move so I'm not in the camera?
We'll talk about it as a class. Yeah.
Discussing, right?
Yeah.
Maybe you should ask her because
Hop over next to mine.
Wait, Mr. Simpson, is the equation of momentum
Fine, if you actually scoot sideways, you just don't want to be in it, right? Is that right?
I just don't want to push it off the table though.
It's all good.
Okay, you're sitting on the end, that's fine.
Yeah, alright.
Wait, the equation of momentum is like P equals N.
Starting to bug my
Equation from like momentum. Momentum.
Okay, so energy
We
is
forgot. Nobody remembers. I asked everybody.
What's the definition of momentum? What do we even call it? Remember?
Force times time.
Oh, force times velocity.
it's light.
That's what I was
Yeah. Oh,
It's light. Heat. Work.
An old German word.
Work is movement. I don't know any of this. And then power.
like I remember a lot. Okay.
Maybe I know it's force.
I'm just laughing.
The definition pretty much, I mean, the formula is pretty much.
Wait, did I say it again? I was just thinking about it. And I said it. So sorry. Your back is disgusting. I just want to be held accountable. I apologize.
It's joules.
Maya Alvarado is responsible for everything said.
Okay, is light, heat, work, movement, power is. I've never even I don't understand. Power is what?
I just put in physics class for all of them.
In physics class. What do you put for power, Maybe? Maybe, what do you put for power?
I'm not even on there. I'm on energy.
Okay, what do you put for energy?
Hey, what do you put for power? Hey, you're right there.
Energy is like really. Huh?
Keep saying bad words.
Oh my gosh, we have to say
That's what another
Like I said, no.
I do mine not.
I was like, in his camera.
Oh, I have the purple.
Watch when you're watching it and be like, oh, wow, who's that?
Ramses, I see you and Anna.
Oh, yeah.
You guys, I honestly don't sabotage.
No, no.
That's
It wouldn't be sabotage.
Okay, what's power?
Me.
I see nothing. I see studio.
Master. See, I don't bench.
Hey, Seth. So far Seth. What's power?
I don't know.
Caroline, what's power? Maybe, do you have blood? Maybe. Do you have blood?
No, I'm sorry.
Maya, do
Okay,
you have
everybody,
blood?
eyes over here. Eyes over
7?
here.
Okay, perfect.
The first word was force, right? What was the meaning of force? Say it louder. Okay, everybody together. Good. And what was the equation of force? Say it louder. Good. Could everybody say it together?
F equals
Good. And what were the units of force? Louder? Good. So remember, F equals MA. And if you don't know the units of F, you could just say the units of mass is what? Say it louder. And what are the units of acceleration? Louder? Meters per second. Meters per second. Good. So in physics, you would hate to say that was a force of 10 kilograms meters per second squared. So instead we say what?
Newtons.
We just say that's 10 Newtons. So what is a Newton? It's 10 kilograms per meters per second squared. Good. So where have you heard this word in everyday use?
Physics class.
Star Wars. Star Wars? Okay. You know, all of these words, in my opinion, I watched some football, I just hear commentators say these words all the time. So when it comes to sports, I hear these words. Maybe you don't, which is okay. What was the next word?
Momentum.
Momentum. Does anybody remember the meaning of momentum?
Mass times velocity.
Yes, that's the equation. Very good. And what was the symbol?
Mr. Simpson said that the definition, or the formula was practically the definition.
Ooh.
So,
Okay.
yeah.
Okay.
You guys, in
What,
word,
you just
in
said
word
that right.
form, what
I
was
remember
it?
right here you said.
Inertia in motion.
Oh,
And if you know how to read that formula, you can see
he
that.
said the formula there.
Okay, you had the question, what were the units of momentum? And I told you, I asked you, what were the units of mass? It's kilograms. What are the units of velocity? It's meters per second. So the units of momentum is kilograms meters per second. And nobody likes to say this, so some people call it a Newton second.
Isn't it joules?
No. Okay, so what is the meaning of momentum? Let me ask you guys a question. You guys watch football?
Yes.
Okay, when we're talking about running backs, why is it so difficult to tackle the running back?
Because they're short and have a lot of. Because they're short and fat, but they're
Because they
fast.
have a lot of, what do you mean they have a lot of momentum?
Their massive build and speed.
Their speed. Good. So is it very difficult to tackle something with a large mass and a large velocity?
Yes.
It's very difficult. Okay, so let me ask you guys, who is like the greatest running back in NFL?
Jamal Charles.
Marshawn Lynch.
I said, who's the greatest running back in NFL history?
Jesus. Eric Dickerson.
Jamal Charles.
Okay. If there's a 200-pound man and he is not moving, is it easy to tackle him?
Yes.
If there's the same 200-pound man and he's moving as fast as he can, is it easy to tackle him?
No.
It's going to be difficult. So the point is, the larger the momentum of an object is, say it.
The larger the momentum.
Okay. The larger the momentum of an object is, the more difficult it is to stop
The
it.
more inertia.
The more inertia
They
comes,
have.
the more momentum. So this is why when you see those big semis, they don't stop. What do? They just keep on trucking. They just honk their horn, right? Because their stopping distance is going to be so great. They're saying, you better stop, because I'm not going to stop. So let me repeat what I just said. The larger the momentum of an object is, the more difficult it is to stop it. And this is why you want running backs to run as fast as they can. Because if a running back is running very fast and you tackle him, which way does he fall? Forward. Falls forward. Is that a good thing or a bad thing? That's a good thing, because he just gains some yardage. You don't want a slow running back, because it'd be easy to tackle him. Any questions about momentum? Yes. Say that one more time. Correct. Say that question one more louder. Okay, so what's the meaning of a vector?
An arrow.
It has a number and direction. Very good. So a force is a vector, and momentum is a vector also. Thank you very much. What's the next word?
Energy.
Okay. Can somebody tell me the meaning of energy? Joule. Okay, the units are joules. Very good. Okay. Very good. Did you want to say something? What do you mean transform? Transfer is what? Well, what about someone from this side? Well, what is the meaning of energy?
I just put like light and heat and things like that are
Something that
energy.
doesn't work.
Good. Something that does work.
Guys,
Okay.
what can energy do?
Work.
So check this out. You need a nice dress to go to prom, right?
We're only freshmen.
You need money to buy food, right? So you need what to do work?
Energy.
Very good. You need energy to do work.
Make money.
Can you read that? Energy. We need energy to do work, and these are just two examples. Kinetic energy is the energy of a Did you guys know kinetic energy?
You don't know the formula yet?
Oh, okay, I'm
You know
sorry.
that kinetic energy is energy.
Guys, eyes over here, eyes over here. Kinetic energy is the energy of a moving object. Its units is 1/2 mv squared. M is the mass. No, it's not the same thing.
Oh.
V is the
Got it.
velocity. Good. And these are just two examples of energy. GPE stands for gravitational potential energy. M is the
Mass.
G is
Gravity.
gravitational acceleration. In our Earth, it is
9.8.
good. And H is the height. So the higher you are, the more GPE you have. The lower you are, the less GPE you have. You don't need to memorize these equations right now. I'm just telling you, we need energy to do work. That's the important thing. And the units of all energy is joules. Energy is a scalar. So what was the meaning of a scalar? Do you know the meaning of scalar? It just has a number. A scalar is a number. You guys know that. If you don't, that's okay.
Well, how come
First semester.
Never thought of that.
I don't remember.
Like 10 years ago. Okay, guys, next word. Work. Yikes. Let me cover that. What is work again? What is the meaning of work? Something that students don't like to do. That was very funny. You should be a comedian. What is the meaning of work? I want to hear someone from this side.
Movement.
Movement. Getting certain things done.
Okay, getting things done specifically in which way? What is the meaning of work? Someone from this side.
Power.
When you move something.
Say it louder.
When you move something.
Beautiful. Work is when you move something. Okay? We need energy to do work, and work is done when we move an object.
Oh my god, where's this for everything?
Let me repeat that. Work is done when we move an object. The units of work is the force of the push of the pull times the displacement. Displacement is distance plus a direction. And forget about cosine theta. And the units of work are?
Joules.
And the units of energy are?
Joules.
So if they both have the same units, what does that tell you?
They're
both really, really close to each other. They're so close to each other, some people even might say they're the same. So remember what I said, we need energy to do
Work.
very good.
Work.
So, let me ask you guys a question. If Mr. Simpson gave you a test, and this test had questions that are, disorganized, and he asked you about force and energy and work and momentum, would you guys understand the difference between these?
He does that all the time.
No? Not yet. Okay. Well, it's okay. It just means you need more practice. That's all it means. Okay, the last thing is power. Does anybody know the meaning of power?
A force.
Good, good. Power is how fast we move an object. So the faster we move an object, the more power we have. Very good. So I hope you could read this. Power is work over time. And what are the units of work? I'm sorry, what is the equation for work?
work over time.
Force times displacement. And what's displacement over time?
I got you.
Does anybody remember? What's displacement over time?
Wait, distance or displacement? Distance or displacement?
Yeah, distance over time is? Say it. Very good. So power is the force of the push or the pull times the velocity of the object. And this has units of joules over seconds, and nobody likes to say joules over seconds, so we say?
Watts.
What?
Good.
What?
Watts.
What? What's on what? What's on what?
So maybe you guys could go home and read the second column, and then read the third column, and you could just have a good laugh. Right?
Wait.
Where?
Say what?
Never mind. Never mind.
Okay. Let's turn the page. I was going to show you guys an awesome YouTube video on energy, work, and power, and then we were going to discuss it, but that's okay. We don't need to do that.
But why can't we do that?
We're not able to pull it up for some reason. The school keeps blocking it.
Our good friend Patrick Henry will not let us watch YouTube.
Mr. Simpson?
That's okay.
Mr. Simpson?
Already, they're not allowed to do it.
Oh.
Are we allowed? I mean, are we trying to turn this in?
It's okay, it's okay.
Guys, this is going to be part of your lecture notes, remember?
Okay.
So, if you guys look at the middle part of the second page, it gives you an equation. Right here. It says work is equal to the change in kinetic energy. Do you guys remember what delta means? Good. So delta is like final minus initial, right?
Yeah.
Okay, so maybe whatever I write, you could write up here because you have all of this free space. Sorry. Okay. So this is just a question I'm giving you guys, and all of you guys are going to drive soon, hopefully, right?
Yeah.
Stopping distance versus speed. Okay? I just told you work is equal to the change in energy, kinetic energy. What was work equal to? No. From the first page, what was the equation for work? Good. The force times the displacement. Change in kinetic energy is going to be what? Kinetic energy final minus kinetic energy initial, right? And I wrote it down right here. Change in kinetic energy is kinetic energy final minus kinetic energy initial. And that's equal to 1/2 mv final squared minus 1/2 v initial squared. What's your final velocity minus what's your initial velocity? The mass doesn't change, right? Tell me if I'm going too fast. Am I going too fast?
No, you're okay.
Thank you. So I just asked the question right here. How does the stopping distance change when you double the speed of a car? Or if you triple the speed? Let's just work with the first question. How does the stopping distance change when you double the speed of your car? So say that one more time. Okay. So some people think that if you double the speed of a car, you're gonna have to double the stopping distance. Does anybody else have another idea? What? What do you mean it's squares? If you double the speed, what happens to the stopping distance? Give me a number. Okay, so let's do it together. Or better yet, let me do it for you. Ta-da.
Wait, you took off your sweater just to put it back. You took off your sweater just to put it back.
So remember the question. You double the speed of the car, and how much more stopping distance do you need? So in step 1, you're going at a velocity v. Step 2, you're going at a velocity 2v. Everybody put your pencils down. Just try to understand what I'm doing. And once you understand, then you can write it. Some of you are putting your pencils down for 5 times. Okay, so like I said, force times displacement equals change in kinetic energy. What's going to be the final velocity of a car that stops?
0.
0. So this is going to be 0. Good. So force times displacement is equal to minus 1/2 mv initial squared. And I'm just solving for displacement. Ta-da! So I put the mass of the car, I put the velocity of the car, and I put the force of friction between the car and the road. Okay? That's when I'm going at a velocity v, step 1. Now step 2 is when I'm going at 2v, right? The kinetic energy is velocity squared, right? So what's 2v squared? 4v squared, very good. So it's like this line is equal to this line. The only difference is I have this 2, right? So I factored out the 2, and I solved for v2. So I put f on the bottom here. This 2 I put outside. And now I have minus 1/2 mv initial squared over f. That goes to the bottom, and I factored out the 4. So compare this number with this number. If you double the speed of an object, what happens to the stopping distance? It increases by? 4. Good. So So is it better to drive fast or to drive slow? It's better to drive slow because your stopping distance will be
Not very much.
Slower.
not very much.
Yeah.
It will be very short. Very good. Okay, question for you guys. What happens if you triple the speed of an object? What happens to the stopping distance?
3 times.
How many?
3 times.
Not 3, because it's going to be 3 squared.
9.
9. So if you triple the speed of a moving object, the stopping distance increases by 9. Is that a good thing or a bad thing? It's going to be a bad thing. Because if something comes to the road and you need to stop, well, it's going to take you 9 times as long to stop. I want somebody to read. Do you guys see it says facts about energy? Could somebody read the first fact about energy? Yes.
The average car is only about 30% efficient.
Very good. Is that a good thing or a bad thing? 30% efficient. So you put $30 worth of gas, and how much do you get out?
30.
You get $9. The other $21 is thrown away. That really sucks, right? Yeah. It's like you're literally burning money. Okay? Did somebody read the second fact?
About 70% of electrical energy in the U.S. comes from fossil fuels.
Good. Thank you. Who uses electrical energy?
Everyone?
Everybody, right? And is fossil fuels a good thing or a bad thing?
Bad.
There's a lot of air pollution, there's a lot of water pollution, right? When it comes to fossil fuels. Can somebody read the third one? Yes.
About 21% of the electrical energy used in the U.S.
Thank you very much. Is nuclear energy a good thing or a bad thing?
Good.
No, bad.
There's a lot of nuclear waste, and no city wants to take that waste. Do you understand what I'm saying?
Yeah.
So let's say you're San Diego, you have a nuclear power plant, and you call another city. Hey, do you want our waste? What are they going to say?
No.
No. Deal with your own waste, right?
How do you get rid of that waste?
How do you get rid of it? That's a good question. So what do most people do? They don't burn it. With nuclear energy, what do most people do?
Decompose it.
It takes a long time to decompose it. So what do they do?
Bury
No.
it. Bury it.
They bury it. Very good. Very good. If you put it in the ocean, you better not eat seafood, right? Yeah. Okay, somebody want to read the fourth one? Yes.
About 74% of the electrical energy used in France comes from nuclear energy.
Beautiful. Thank you. So every country has a different solution to their energy problem, right?
But France is small.
That's a good point. But the point is, they might have a different solution because they're a smaller country. If you go to the Middle East, what are they going to use?
Wind turbine.
What do they have in the Middle East?
Wind, a lot of wind. Sand, fossil fuels, oil.
Oil. Good.
There we go.
Good.
Took 5 times.
China and America have a lot of coal, so we use a lot of coal.
Does coal count as a fossil fuel?
Coal is a fossil fuel because it is non-renewable. You are correct.
I'm learning.
Okay, we have problems. I want to do 2 problems together, and then you guys can get in groups and do the rest, okay?
Okay.
I know it's 6th period and your mind is probably somewhere else. But let's just do 2 problems together right now. Somebody read problem number 1. Yes.
Renetta Gass is out with her friends. Misfortune occurs and Renetta and her friends find themselves getting a workout. They apply cumulative force of 1,080 newtons to push the car 218 meters to the nearest fuel station. Determine the work done on the car.
Thank you so much. So the last sentence says determine the work done on the car. So what's the first thing you should do?
Get the work
Get the
for.
equation. So what's the equation?
W equals F times D.
Good. Work is equal to force times displacement. So do we know the force?
1,008 newtons.
Good. I hope you can read that. Do we know the displacement?
218 meters.
This is just plug and chug, right?
Mm-hmm.
And then you have the answer. Very good. Thank you. Let's do one which requires work and power. Does somebody want to read question number 4? You guys are so shy. I don't want you to read again, I'm sorry. Yeah, thank you so much.
During the powerhouse lab, Jerome runs up the stairs, elevating a 102 kilograms body, a vertical distance of 2.29 meters in a time of 1.32 seconds at a constant speed. Determine the work done by Jerome in climbing the staircase. Determine the power generated by Jerome.
Thank you so much. So A, what equation do we use for A? The same one. Very good. Thank you. Do we know F? Do we know F, guys?
No.
Okay, how do we find F?
Equation.
Use the equation.
What equation?
The one over there. Oh.
Okay, but my question for you is, what's F?
F equals mass times A. Wait, M times A, momentum.
Yes, say that louder.
F equals M times A,
Okay, good. So what's M?
mass.
Okay. What am I looking at? Right here. 102 kilograms. So remember, the force of gravity is weight. Is this the weight of the object?
No.
This is the mass. So how do we get the weight?
Multiply by gravity.
And what's G?
9.8.
9.8 meters per second squared. Good. So now this is the force of gravity. Do we know the distance? 2.29 meters. Thank you very much. And then that will give us work. Now, B says determine the power generated by Jerome. How do we find the power? What's the equation for that?
Equals W over T.
Power is work over time. Very good. And what's the time?
Force over time.
No.
1.32.
Good. And work, we got it from here. Did somebody use a calculator to find this number? Could somebody?
Yeah. Use your phone as long as it's in calculator mode.
102 times 9.8 times 2.29.
999.6.
999.6. Okay, thank you. And this has units of joules. So what's 999.6 divided by 1.32?
8.7.
One more time?
Or 757.7.
Okay, we'll say 757. And what are the units of power? Not joules, watts. Good. Ta-da. Okay. So we did 1 and 4 together in groups of 2. Just start with number 2 and go down from there. And if you have a question, I'll just be walking around. Sound good?
Sounds good.
Okay.
Wait, did we do this work on the back?
No, I don't know. Yeah, I guess. This one here. Why don't you come down here and wait?
Right there. I'm fine.
Or down here. Is it on me right now? I don't.
Okay, so for number 2,
Special shout out to Man Jesus.
okay, so for number 2 we have to find the work, and then it says Lamar Grant, U.S. powerlifting star, became the first man to deadlift 5 times his own body weight in 1985. Deadlifting involved raising a loaded bar. 300 kgs.
Did you get the first one?
Start with number 2. And if you have a
Yeah.
question, I'll just
No, I didn't.
Yo, can I sit up right there and then scoot over a little?
Sure.
How are you guys doing?
Jeez, this was high.
Alright.
Dude, that thing could probably see me the whole time.
I didn't know if you knew that or not. Okay. So
Why would you lie?
I said it because you can only see like this part, like your shoulder, like not your face, but your shoulder. Wait, hold on. For work, what do you do?
Getting off me a little bit. What?
Wait, what's the first one? Oh, force time distance. It's 300 kg force. What is that? That's fast.
School is so Look.
I know, actually, that's wait, what is work?
I want to touch that thing so bad. Oh, dropped my pencil. I want to touch the computer. It looks so nice. You know who's such a great teacher is this guy? He's so much better than Mr. Simpson.
I see him in 20 years being like Mr. Paul Hewitt.
Yeah, Mr. Paul
Very
Hewitt,
awesome.
like the next Paul Hewitt is standing in this room right now. I just hope that they let him become a teacher because he's a great teacher. I would much prefer him than Mr. Simpson. Mr. Simpson, I mean, he's okay, I guess. I mean, he gets the information to us, but it's not the best. I mean, Newton was a better physics teacher. Newton's like Newton may be dead.
Okay, I don't know.
But you know who isn't dead? The guy's name here. The guy here with us today. Mr. Jid.
Hold on. I don't know how to do 2. How do you find force? I'm just gonna do
Force is mass times acceleration.
Yeah, but this 300 is not force. Force is...
Math, that's mass. You don't.
No, I know, but I need to find force. Like, I don't know how you find force.
You multiply it by acceleration. And then 1999.
There's no acceleration.
Just times these two together, and that's your answer.
That's not right, though.
It doesn't matter. If Mr. Simpson was here, he would still give us the point because he's a terrible. I'm kidding. I'm kidding.
Are you talking to
Talking to Mia Alvarado. She's a freshman.
Seth Far, freshman. Seth the freshman.
Yeah.
He's such a freshman. While training for breeding season, 180 gram male squirrel is 32 digits in a minute. We have to also
Sean.
find force.
Sean. Kyle.
Wait, how is force determined? Like, what are units? Newton's force and velocity?
I guess.
Weight divided by
Fucking stupid. Slide right out of it.
What?
Slide right off this stool.
One time I was like this, and I was falling back, and I was like sleeping. I was so scared.
Dude, I would fall off this thing. I feel like
That
standing.
one's like unusually tall.
I want to like saw the freaking wires off it.
Like, look, switch really quick. Oh wait, no, I can't keep sitting here.
Yeah.
Ow.
No, it's okay. Just skip it and go next.
These are all hard. Just wait, I'm just not good.
Is that what you got?
The first asteroid to be discovered is Ceres. It is the largest, most massive asteroid in our solar system. There's a typo in here. Oh, 120. In our solar system, asteroid belt, having an estimated mass of 3.0 times 1021 kg and an orbital speed. Determine the amount of kinetic energy. 6.8.
Could somebody tell me, or the class, how to do number 2?
No, that one's too hard.
Is it too hard?
I don't think it's correct. Like,
I got it, but I don't think it's the right answer.
no, you didn't.
Okay.
I did 200
Everybody listen up.
Because I told you to multiply
The more problems you do now, the easier life will be later, okay?
Oh.
So,
That's something a
that's
good
just something
teacher would say.
teachers say, right? Somebody read number 2. Somebody want to read number 2?
What did you skip? Worms is ring number 2.
270.
yes, same.
Lamar Grant, U.S.
I'll read it.
Yes.
Okay. Lamar Gant, U.S. powerlifting star, became the first man to deadlift 5 times his own body weight in 1985. Deadlifting involves raising a loaded barbell from the floor to a position above the head without an outstretched arm. Determine the work done by Lamar in deadlifting 300 kilograms to a height of 0.90 meters above the ground.
Thank you. So what equation should we use? Guys, what equation should we use for number 2?
Work.
Work. And work is equal to what?
Force times displacement.
Force times displacement. What's the force of this?
Do you have to find that out, or is it just?
It's the force of gravity, which is the weight of the object. And what's the
Okay.
weight of the object?
300 kg. Or that's the mass.
300 kilograms is the mass, times 9.8 meters per second squared. So mg is equal to the weight, right? And we multiply this by what?
6.
Oh, okay. Okay.
Louder. 0.9 meters. Very good. So this is the force of gravity, and that's the displacement. And that's how you do number 2.
That's what I thought.
Guys, I see you guys. I know a lot of you guys are not writing this down.
We
but
are.
If you write this down now, you're likely to be easier later.
How?
So please write this down now.
I'm writing
so we
this
have
down.
some models to look at.
Wait, let's see. What'd you write?
Wait, all the values, all the like things that you put on the bottom, are those just like the units, or?
So I said work is force times displacement. This is the force. This is the displacement. So the force was 300 kilograms times 9.8 meters per second squared, and the displacement is 0.9 meters.
Okay.
And I don't have a calculator. Does somebody?
2,646 joules.
Do you guys know what a deadlift is?
Yep.
A deadlift. Yeah. I could not deadlift twice my body weight, and this guy did 5 times. That's pretty amazing.
I think I could. Nah,
Say what?
just kidding.
Yeah, I don't think.
I probably could do half my weight.
Yeah, a lot of people deadlift, but 5 times their weight, that's amazing.
70 pounds, I think. 75.
What?
Yeah. There's so many. There's bodybuilders everywhere.
There's one on your shirt.
Did somebody do number? Did somebody do number 3?
No.
Yes.
I got stuck on 2.
Okay, raise your hand if you did number 3. I heard a yes. Do you want to go up and?
Really though.
Yep, she said she does.
I did it right.
She wants to.
Do it.
Do it. Do it.
Do you want to?
Do it. She wants to.
I don't know.
Wait, Maya, what'd you get?
Can I go do it? Can I do it?
I got it. 3,200.
That's right. That's right.
That's good. That's what I got.
That's it. Okay, but do you have to multiply by 9.8?
Yep.
I did it.
I didn't get that. I got something else. I think I did it wrong.
She's gonna go do it.
I didn't do it right.
You did it correct. I'll keep the camera on you. It's just a dress code.
Dress code.
We have 9 minutes.
Shouldn't be on our phone.
Oh wait, never mind. It's right here. I totally forgot.
Okay. So, does somebody want to read number 3? You guys are so quiet. Okay.
Whoa, good job.
The question says, determine the total work done on the squirrel while moving upward, right?
Get it right.
It's up here. Okay. What was the equation for work again?
Force times.
Force times displacement.
Force times times.
What's the force of gravity or the weight of the object?
9 point. Wait, force of gravity or the weight of the object?
The force of gravity is the weight of the object.
Oh, okay.
It's the same thing.
Wait,
380 grams. Grams is units of what?
Mass.
Mass. So what do we got to do?
Multiply by 9.8.
Okay, both of you are right. Say what you just said.
Divided by 1,000.
And you said?
Multiply by 9.8.
Good. So we got to change grams into kilograms. So how many kilograms is this?
38,000.
Good.
Oh, dang it.
And then we're going to multiply this by what you just said?
9.8.
9.8. And then what's the displacement? 8.5 centimeters, but we got to change centimeters to meters. So 8.5 centimeters is how many meters? 8.5 centimeters is how many meters? You're close. Good. 0.085 meters. Okay? Now the school did how many push-ups?
32.
32. So we got to multiply this bad boy by?
32.
32. Good. And this gives us a number, and that's our answer. You're welcome. So this is the force. This is the displacement. And the squirrel did this 32 times. That's why we have to multiply it by 32. Does somebody have a number? 10.1928. And what are the units?
Joules.
Joules, right? Good. You guys should write this down instead of giving high fives.
Ooh.
Good. I just want you guys to go home and have something to look at. Because the more examples you have, the better for you. Are there any questions about this? Guys, on this page, I told you where you could find the solutions. Guys, listen for like 2 more minutes. On the bottom of this page, I showed you where you could find the solutions. It's an internet website. And there's 2 more great resources if you want to know about work, energy, and power. There's a lot of pictures, and it explains this stuff very well. I'm taking a class right now, and this is probably the most important thing I'm going to tell you today. It says 48% of forgetting occurs in the first 20 minutes, with 62% occurring within the first day. So 20 minutes after class, you're going to forget about 47% of everything I taught you. And after 1 day, you're going to forget about 62%. So what's the solution to this problem?
Writing it down.
Keep practicing.
Writing it down, studying it, practicing it. Perfect.
Watching this video.
That makes so much sense. Yeah, you have to see it again and again and again, right?
What time is it?
So please, this worksheet that I gave you, please look at it again and again and
Do you
again.
want us to turn this in right now?
Are you looking
Thank you,
at
guys.
Oh, yeah,
Guys,
that's fine. Yes, I remember.
listen,
Everyone
this
remembers.
worksheet is going to be part of your lecture notes. Just leave it where today is.